Welcome to the Exec Exchange, 15-minute podcast in which a leader from the water sector shares a story to inspire, inform and educate other water sector leaders around the globe. My name is Piers Clark and my guest today is Bob Taylor from Portsmouth Water. It's the second time we've spoken to Bob. We did a podcast with him a year or so ago. And what we're going to be talking about today is what Portsmouth Water has been doing around network management and some innovative approaches that they've been adopting. Bob, brilliant to have you with us today.
Thank you very much, Piers. It's great to be here again.
Now, we start with a little bit of your background, so just fill me in. How long have you been at Portsmouth Water? What did you do beforehand?
I'm a water industry veteran, you might say, of more than 40 years. So I came to Portsmouth Water in 2018. Prior to that, I've worked in a number of water companies in the UK and internationally as well. It's been a really interesting journey with the company, Portsmouth Water. It's a good company, and we are, I'm proud to say, building the first new reservoir in the UK for 30 years at Havant Thicket. I think a lot of people have probably heard about that. It's quite high profile, which is another great project to be involved in.
Havant Thicket, I think, will be a whole podcast in its own right at some point in the future. Now, we're chatting in the middle of June. We're in the middle of a heat wave. And before we press record, we were just chatting about the fact that in Portsmouth Water, you don't need to panic when you get into this sort of hot weather. Now, why is that?
We have a very robust and quite resilient infrastructure in a number of ways. So we get all of our water from the Chalk Aquifer underneath the South Downs on the south coast of England. About a third of it comes from springs. About another 60% comes from 20 or so sites dotted around. And then the rest comes from a relatively small surface water source from the River Itchen. So we're able to move that water around our system quite easily. So we're not heavily dependent on single large treatment works, which if they have a problem, they fail in some way, they have a huge impact. We've got a couple of what we would call our bigger sites, but in general, it's quite a distributed system in terms of production, and we can move water around. We have on average about double the standard of service reservoir storage, which is where we store the treated product before it goes to customer. And nearly all of our customers are downstream of those service reservoirs and not on the way to the service reservoir. So it's a very resilient system. We are pumping at a very constant rate. We don't have pumps that are pumping to match demand on the system because all of those variations in system demand are managed through the service reservoirs. We also have a lot of pressure management as well on the south of our area, the coastal strip, which also keeps pressures at a more consistent level between day and night and helps with leakage and bursts and other things.
It's a beautiful water company. And just for the audience who aren't familiar, how many people do you serve?
In round figures, about 750,000.
Wonderful. Now, the topic today is around some of the things you've been doing to manage non-revenue water and better manage your network. And in particular, you've been working with a company in the Netherlands. Can you tell me the story? What was the problem that you were trying to solve? What did you do? How did it go?
Starting at the sort of highest level, leakage management and leakage reduction, I would say water resources management, particularly today, it's more important than ever for companies in the UK in the face of climate change, the need to grow our economy, to be treating the environment well. These are very big concerns that we have. So keeping our leakage down to a reasonable level is part of the overall challenge, including reducing customers' usage, efficient per capita consumption. These are all part of the demand equation, you might say. And we've always been quite forward thinking in terms of the smart networks concept, which started to manifest itself probably about 15 years ago with the onset of more readily available, cheap kind of information collection products, devices that you can deploy across your system and get better understanding of how the system is operating. So it's part of that overall picture. There's a lot of new technology involved in leakage these days, and we are a little bit of an outlier in some ways in our network compared to many of our colleagues in the UK. And that is because probably only about half of our network is sectorised. And by sectorised, I mean divided up into large district meter areas or strategic metering areas, we call them. So that means that the leakage challenge is somewhat more difficult because district metering is a very good concept, and we are still putting in more district meter areas, but my predecessors felt that district metering wasn't such a great idea because of the reduction in resilience of your network and sometimes the challenges it can present with water quality.
So let's just pause there, because I want to make sure that we bring the audience with us on this. So DMAs, district metered areas, is something that we've been adopting in the UK for quite a few years now. And as you say, you basically take a network, you break it up into individual areas, and you put a meter at the front of each of those areas, and you can then do an analysis of the leakage within those areas. It gives you better insight, but it does also, as you just said, reduce down the resilience of the sites of your overall network, because you've now broken it into individual pieces. And some parts of the world, I think North America, doesn't embrace the DMA approach quite as fulsomely as maybe we do in the UK. Would you agree with that little summary?
Yeah, I would agree with that. I worked in a water company similar to Portsmouth Water in the 1980s, and we covered our whole network with district metering over a period of about 7 or 8 years. I think we were the first water company to do that at the time, and I think everybody has followed suit other than Portsmouth. And I was interested in a product that was developed in Holland, because the Dutch networks are not sectorized. They are open networks like they used to be in the UK, and like half of my network broadly is now. And I was wondering whether that concept produced by this company called HULO, the data analytical concept, would actually accelerate my ability to be more efficient at finding leaks in the non-sectorized side of my network.
And the challenge, of course, is, well, if you haven't got a DMA, how the hell do you get those insights as to what's going on in your underground assets? How do they do it?
The concept is that you do need a certain amount of monitoring around your network. So you need pressure monitors or flow monitors, which are a bit more expensive to install, as we probably know. But you do need to be able to collect, as an input into the model that they use, data from the network to understand, in simple terms, how it's operating in a steady state way. And by that constant real-time monitoring, you can then see whether something has changed on that network.
I love it. So once the AI or whatever it is that's doing it has learned what steady state looks like, then it's looking for deviations from the norm.
Exactly that. And there is a big debate going on in smart networks at the moment about how many sensors you need on a network to be able to monitor it effectively, because we are moving away from offline monitoring of networks to real-time monitoring, speed up the response, not having to rely on customers to tell us when there's a burst main.
And that's great, but only if the burst is visible at the surface. I mean, if there's a burst and the water's disappearing down, it can be there for years before you spot it. So you've seen this company, HULO, in the Netherlands, and you thought they were interesting. So you invited them over to play.
Exactly, yeah. We've entered into an agreement with them to do some trials for us. We've completed those trials on a number of areas where we had varying amounts of monitoring on the network. We didn't install additional monitoring for the purposes of this trial. And that is a question that we're answering at the moment as to what we think, if we expand the trial, what the frequency of monitoring will need to be. But yeah, it's been successful. I think we've monitored 6 different areas. And the initial job was for HULO to set up, with the data and understanding of what's going on in those areas, the baseline of activity in those areas. And then one of my guys went out and opened a hydrant without telling HULO where that hydrant was going to be, and challenged them to pick it up on their model. And in 5 times out of 6, it was successful. And I think there were good reasons in the one that didn't work. I think the hydrant wasn't open for long enough or something like that. And the model is AI-based, but it's also a very, very, I would say, data-rich, high-quality hydraulic model as well.
So let me get this straight. HULO came along and they told you where to put the sensors and flow meters, some of which you already had, some of which you had to buy some new ones?
No, we didn't put any new sensoring at all. We've made do with what we had previously, which in some areas is quite luxurious, I might say, but in some areas it's pretty sparse.
Okay, so HULO come along, they've taken your existing sensors, gathered the data from those, and then from their offices in the Netherlands, they haven't actually had people on site. They've been able to tell you insights as to when you've manufactured leaks in your network.
Exactly.
That's brilliant.
We're at the stage now of deciding whether we're going to go further with this. I think there's a good chance that we will, because I suppose you compare that with the capital investment of installing more district meters. They're quite expensive to install. They take time to roll out. So the whole thinking process was, well, can we avoid that capital investment and also maintain the resilience in that part of the network by being able to pick up the areas where leakage is happening quickly, to then direct the guys who are going to pinpoint those leaks more quickly and fix them more quickly, which is what we're all aiming to do.
I've got to ask, do you have any sense of how big the simulated leak was? Was that part of the test of, well, let's do a short, sharp leak, let's do a big leak, let's do a little leak? Or was it just open the hydrant, see what they can spot?
I don't think they were fully open hydrants, because we can't go around wasting water in front of our customers and spraying it all over the street in that way. It was well controlled, but I think they were like a normal leak. They were running for probably 45 minutes or an hour at least, but at a reduced level, not with the hydrant completely open.
Brilliant. There's a few things I love here. One is that you're the chief executive, yet you've been able to talk a really technical detail about what's going on, which of course I've known you for decades and I'm not overly surprised at, but I do think it's glorious that in the water sector we have some people who are statesmen of the sector that actually know what the hell's going on and can talk about it in the level of detail you've been able to do.
Yeah, leakage is a particular interest of mine. I started in that area, as I said a moment ago, back in the 80s, in my early years in the industry, and I've never moved away from it, plus or minus. And it's great to have seen all of the ways that leakage people around the world have collaborated one way or another through the conferences or through International Water Association. And it's great to see how the supply chain have worked so closely with water companies to develop amazing new products that now are on the brink of a digital revolution. And now, of course, we have smart metering just around the corner. And smart metering is a huge opportunity for us in leakage.
Well, we're running out of time. And as you probably know, my usual question is, if you were to go back 30, 40 years, what advice would you give your younger self? I'm going to give you a different question. I'm going to give you the forward-looking one, because you are a veteran of the water sector. And so my question to you is, what advice would you give someone coming into the sector now? What should they be looking out for? What should they be thinking about?
I think my advice would be to ignore what you read in the newspapers about the sector. This is such an important and vital service, and people who join the sector get huge amounts of satisfaction from working in the sector because it's such an important job. It's a service that brings life to people. It's a service that's intimately connected with natural environments, and people get a buzz in the industry in delivering that essential service. And I've been in the industry all my career. I'm not alone by any stretch of the imagination, and that's because it grabs you, it bites you and keeps you, basically. And there's so many opportunities as well. We cater for so many different types of career, environmental, technical, engineering, and so on. And we've got this massive, heavy infrastructure building program going on in the UK, 10 reservoirs being built. Mine is only the first, and another series of other heavy water transfer projects as well. Our domestic capital investment is up. So this is an industry that's going places.
You have been listening to The Exec Exchange with me, Piers Clark, and my guest today has been Bob Taylor, Chief Executive at Portsmouth Water. Thank you to our sponsors, and until next time, keep asking questions, keep sharing, and keep safe.